Okay, so you've seen how pH works in relative terms. The fact that a pH of 4 is 10 times more acidic than a pH of 5, and 100 times more acidic than a pH of 6. But how do we actually calculate what the pH is if we know the concentration of our acid or base? Here's how we do it. pH is the negative log of the H3O plus ion concentration. So if we know the hydronium ion concentration, all we need to do is take the negative log of that value, and that will give us our pH. Here's how it works. Water actually cannibalizes itself. Yeah, water molecules can actually tear other water molecules apart into hydrogen ions and hydroxide ions. As you remember from the first day of this, the hydrogen ions combine with the other water to form hydronium ions, H3O plus and OH minus. Now, at equilibrium, their concentrations are going to be equal, right? Because it's a 1-to-1 mole ratio. It just so happens that at 25 degrees Celsius, water has a natural concentration of hydronium of 1 times 10 to the negative 7th molar. And because the ratio is 1-to-1 for hydronium and hydroxide, the hydroxide will also be 1 times 10 to the negative 7th molar. Now remember from when we did equilibrium in KSP, KSP is equal to the concentration of the dissolved ions multiplied by each other. KW is like KSP, except it's strictly for water. KW means the equilibrium ionization constant for water.
That's what the W means. Water!
So let's put in the concentrations of hydronium and hydroxide. 1 times 10 to the negative 7th for the hydronium, 1 times 10 to the negative 7th for the hydroxide. And remember, when multiplying numbers that contain exponents, the exponents will be added together. 10 to the negative 7th, 10 to the negative 7th. When you add negative 7 and negative 7, you get 1 times 10 to the negative 14th. This is a very important value which will help you calculate pH of certain solutions. Now, when you add an acid, acids contain hydrogen, which combines with water to form hydronium. So as you add an acid to water, the hydronium concentration will increase. And because of Le Chatelier's principle, hydroxide ion concentration will decrease. After all, this number is a constant, and the only thing that can mess with an equilibrium constant is temperature. So if I increase this value has to decrease so that when you multiply them together, you still get 1 times 10 to the negative 14th. When you add a base, you're adding hydroxide ions. So if you're increasing hydroxide, hydronium will drop. So if we add the OH, this value will go up, the other value has to come down so that when you multiply them, you still get this constant value. What does constant mean? It means it stays the same. So if this goes up, that has to change so that this number remains 10 to the negative 14th. Now this is actually pretty easy if you're dealing with nice whole number powers of 10. If the H3O plus is 10 to the negative 4th, then OH minus has to be whatever it takes for when you add those exponents together, you get 10 to the negative 14th. Because KW is 1 times 10 to the negative 14th. So, if this is 10 to the negative 4th, then OH has to be 1 times 10 to the negative 10th molar. If H3O plus is 10 to the negative 8th, then OH minus has to be 10 to the negative, well, let's see, 8 plus what is 14? How about 6? Yeah. If H3O plus is 10 to the negative 12th, then OH minus is 1 times 10 to the negative 12 plus what is 14? 2 molar. If OH is 10 to the negative 4th, then H3O plus will be 1 times 10 to the negative 4 plus what is 14? 10. If OH is 10 to the negative 13, then H3O plus will be 1 times 10 to the negative 13 plus what is 14? Let me break out my calculator. If OH is 10 to the negative 2nd, then H3O plus will be 1 times 10 to the negative 2 plus what is 14? 12. Now, to tell if the solution is an acid or a base, all you need to do is figure out which of these two concentrations is greater. In this case, 10 to the negative fourth is much bigger than 10 to the negative 10. So therefore, since there's more hydronium, which is what acids have, this solution is an acid. In this case, the OH's concentration is higher. Since bases have hydroxide, that solution is basic. H3O, 10 to the negative 12th, OH 10 to the negative 2nd, that is much bigger, it's a base. In this case, this one's bigger, and that's AOH minus. Since OH minus is bigger, that's a base. In this case, H3O plus is bigger, that's an acid. In this case, the base is bigger. 10 to the negative 2nd is bigger than 10 to the negative 12th, so it's basic. Ab.